Hello everyone. Today, our group will be presenting on the thermodynamics subject. We will be focusing on the biomass, which is the main source for the power generation plant later.
Moving on, introducing our group members. All of us are from Bachelor of Chemical Engineering, and our group consists of 4 members, which is first, Salik Zarif, next, Bartholomew, next, Anissa Yasmin, and lastly, Silas.
Biomass are divided into two components, which are animal-based and plant-based. As for the definition of the biomass, it is stated as organic material derived from plant and animal. It is one of the renewable energy sources that could be used to generate power through steam power generation in particular. When we talk about biomass, the bio itself stands for the living animal and the mass stands for the collective weight of the animal itself, from the skin, bones, hair, and many more. Same goes to the plant, where bio stands for the living plant and the mass is for the amount of matter of the plant, such as the leaf, the stem, and other part of the plant.
Hi, I'm Silas and I will talk about thermodynamical laws involving in this relation. First law of thermodynamics. This law stated that energy cannot be created or destroyed, only converted from one form to another. In a biomass power plant, the energy contained in biomass is converted into heat through combustion. The heat production is then used to rise the temperature of water, creating steam. And also we'll talk about second law of thermodynamics. This law addresses the duration and efficiency of energy conversion. Not all of the energy from biomass combustion can be converted, use both work to inherent loss and limitation. The second law establishes the concept of entropy, which tend to increase over time, implying that perfect efficiency is unattainable.
Now I'll be talking about the main components being used in our power plant. Before any of these processes in the Rankine cycle can take place, we need to combust the biomass medium, which in this case would be paper. So by using 15.2 megajoules per kilogram of paper, we were able to derive the number of paper which we would need, which would be around 114 tons per day. We assume the boiler to be isobaric, and it plays a crucial role as it helps to generate steam, which is then used to drive a turbine connected to a generator for electricity production. The boiler is also responsible for converting the heat generated from the combustion of biomass into high-pressure steam. Our turbine is assumed to be isentropic, and the turbine is a crucial component in the electricity generation process. The turbine converts the thermal energy carried by high-pressure steam into mechanical energy, which then drives the generator and ultimately produces electricity. The condenser is assumed to be isobaric as well. The condenser is a component that is often used to recover and reuse steam after it has passed through the turbine. So basically in the condenser, the phase changes is from superheated vapor back in the compressed liquid. The main purpose of the condenser is to condense the low pressure, low temperature steam coming out of the turbine back into water. This condensation process improves the efficiency of the power generation cycle. The pump in our power plant is assumed to be isentropic, and it produces a high pressure output in order to further drive the compressed liquid back to the boiler.
There are some reasons which we can benefit from the utilization of biomass in power generation plant. First of all, renewable energy. Biomass provide the renewable energy sources that can help reduce our reliance on fossil fuel. Next, the greenhouse gas reduction. Biomass can help decrease the greenhouse gas emission, contributing to the fight against climate change. We will also help the issue of waste management. Since biomass allows us to convert organic waste into useful energy, it will promote a more sustainable approach to waste management. Then it will also contribute to carbon neutrality. Biomass fuel can be carbon neutral, which means that the carbon emitted during combustion is balanced by the carbon absorbed during plant growth. Last but not least, local economic development. Since the biomass energy production plant is built in a large scale, it could create jobs and also local economy, benefiting the communities.
To conclude our calculations for our Thermodynamics 1 course, our work net out is calculated to be 17,990 kilowatts, which is within the 15 to 20 megawatt range proposed. Our overall efficiency would be 9.37%, our backwork ratio is 0.196, and our total amount of steam produced would be 8.7514 meter cubes per second. For future projects, some recommendations for us to improve the efficiency would be by increasing the pressure of the boiler and by increasing the temperature at which water is superheated to. In conclusion, it can be said that biomass is easily sourced from organic materials and offers high power productions through various processes. As a renewable energy, it reduces emissions, fosters energy independence, creates jobs, and preserves natural resources for a sustainable future.